section control. That's something we upgraded to a few years ago, and I actually brought one here today to show you. Here's a picture, one of the pictures we took in the summer, and if you can see the spots in the field. This is something when you're driving down the road you can't hardly see. What this is the hilltops of the field. Actually, you can see a line right here, and that's where in the past they put manure on and they cross the field like that, and this is where they turn around. So it's where the compaction has caused the roots not to be able to go down through the soil profile and extract water. So these are just some of the trends we can pick up from the air. And then we can actually overlay these with a yield map, and that'll tell us if this spot yielded badly because of compaction, or if it's just a variety thing, or what exactly is going on there. Green Star yield mapping, this is our first yield monitor that Dad bought in '94 to put on our combine. And as you can see, there's not much there for this stuff on it. It basically just outputs a number. It uses a sensor on the combine which checks the moisture, and it checks the yield as you're going through the field every 8 seconds. And then it just records it as a point. So every 8 seconds it basically writes down 2 numbers, the weight and the moisture. And so from that you get this map, which is kind of pixelated, but each one of those points are different. Now as you can see here, this is a little smoother version of it, so you can kind of ascertain more trends across the field. This is all corn, and this is just a better variety. That's why it yields like that. I mean, that's why it looks like that. And the green is good, red's bad. It's pretty self-explanatory that we have a variety change there, because that's where we plant the whole field across, a different variety. Whereas in here, this is probably a hilltop. So it's just it's a good way to compare different practices. A few years ago, we went to these insight controllers, which I can show you on here. This is one of our insight controllers that we have in the tractor, and we've got 2 of these in the tractors that we use most of the time. And it's a touch screen. It's all operated off touch. It's a pretty versatile system. We utilize automatic section control, which I don't know if you can see on this picture. It shows the rows shutting off as it approaches the waterway and then turning back on the other side. This is basically what it does both for planting and for spraying. So we have 5 sections on our sprayer. It's 90 feet wide, but we have it broken down into 5 sections. So when we come up to the end, it'll shut off 1 section at a time, so we reduce overlap. We also use these for logging, so any anhydrous or anything we put on, we've got it documented, and it's geo-referenced, so we know exactly how much we put on where in the field. So here's a synopsis of the section control. You can see the insight controller here with the different zones in the field. Now, this saves nitrogen as we spray nitrogen on with our sprayer in the spring. It also saves chemicals, so we don't overlap Roundup or other chemicals across our field to get the appropriate rate where it's needed. It also saves seed. Seed keeps getting more and more expensive as we go along here, so this is a very big seed saver over the long haul, because you can actually break it down to each individual row of your planter if you like. So we have a 24-row planter. We could have it broken down in 24 sections. Right now we do 12 and 12 as we come up to the end, where we're catching up with that technology. So this can save anywhere from 5 to 10% depending on your field size and shape, orientation mostly. If there's a lot of waterways or the end of the field is slanted, then you get a lot more of that. As if it's square, then the whole planter shuts off at the end. It's not a problem. So here's a variable rate fertilizer application. So these are all grid soil sampled. We go out every 3 acres and take a grid sample, or 2.5 acres, and then we take that sample and send it into a lab. And from that comes this map. It shows all the areas where we're deficient and all the areas where we need application of different chemicals in fertilizers. So here's phosphorus and potassium, for example, and this is the same field. So what we'll do is usually we have a custom applicator come in and do it, and he has 2 different tanks on his vehicle, and each one is driven separately. So as it's going across the field, the first tank can be applying to this map, and the second tank can be applying to that map, spreading it out across the field. So you get the fertilizer where you need it instead of a broad application. Here's some of the logging. This is actually a report that we print directly off of this Insight monitor. It comes out as a PDF file. We can print it off, and it shows exactly where we applied what in the field and at what rate. It shows the different rates, and as we load the sprayer, we put in all the different chemicals and even the water we put in there, so we know exactly what's coming out of the nozzles. And then it gives the amounts here, so it gives us the average rate, but we can also find specifically what goes out at every point in that field. Autopilot guidance is auto steer, where we can be in our tractor and we're not steering. Now this not only is an operator thing, but this is also allows us to do a lot of better things. I don't know if you can see the green in here. That's a row of corn planted right in between old corn stalks. And what it is this is a strip till bar that did this. And so we're only tilling about 10 of the 30 inches as we go across the field. This leaves all this residue on top, which can absorb moisture all year round, and it helps to feed the plant with carbon as the plant grows. So this is it's actually classified as no-till practice because there's so little tillage compared to other conventional tillage practices. So this is basically what autopilot, one of the reasons we went to autopilot. We wanted to pursue strip till, and it's almost impossible to do it without auto guidance. Here's some of our conservation programs we use. It's a little hard to see it. Conservation Security Program participant. There's different classifications. One's soil management for reduced tillage applications. Nutrient management or variable rate fertilizer application. We also have energy management, which is applying at or below agronomic rates. A lot of people put on what they think the crop needs, but we actually use the rates that are recommended by the university all the time. We never exceed them. Stewardship recognition, we've also implanted these buffer strips. This is actually right by Dad's house. Here's a field of corn out here, and here's the lawn here. So there's these strips we put in all over the farm. They're spread out. Some are within a quarter mile of all the land, some are within half a mile. And what that allows migratory birds and wildlife is to use these strips. So they use them in the spring, and they use them for hatching their young, and then they fly off. But there's always a little percentage of our acres that's dedicated to this so that they can take advantage of that. So our specific practices is we use reduced tillage strip till. That's made possible through auto steer. Our grid soil sampling, variable rate fertilizer application go along with that. The refuge strips, spring application of nitrogen. This is something we do. We actually spray on a little bit in the spring, and then we come back and side dress during the summer while the corn's up and growing. And this allows us to spoon feed our nitrogen application as we're going so it doesn't leach down through the soil and water profile. And that way the plant gets to utilize it, and we get to utilize it cost-wise, and the plant gets to utilize it for agronomic-wise. Integrated pest management, we spray when it needs to be sprayed, not all the time, not a blanket application. We go out there and scout and make sure there's insects in the field before we go and spray it. We also use fertilizer at or below agronomic rates. So here's our green farming. We strip till, which in turn reduces fuel by quite a lot. It almost probably half, would you say, reduces the fuel consumption by half of conventional tillage. And it also allows us to only do one pass during the year. So we do one pass in the fall, and then we're ready to plant in the spring. We don't have to go back and work it once or twice more. We also reduce soil erosion, which is becoming a big problem, or has several years ago, until we adopted more of a minimum till practice. It's a little hard to read. Sequestering carbon. No-till has been proven to sequester 0.2 to 0.6 metric tons per acre of carbon, and I looked it up yesterday, and that's the equivalent of what 132 cars put out in a year per acre, or well, per year, and that's so over our total operation, that's how many cars is the equivalent for us doing strip till practices. And what it does is it sequesters the carbon into the plant, which stays on top ground. We don't break it down right away, and then during the summer, as it breaks down, our corn plants can absorb it. So we also participate in the Conservation Security Program, which has these buffer strips and other practices associated with it. And we also have entered some of our low ground into a wetland restoration program. So we've seeded into natural prairie grasses and flowers, and it's basically an overflow area that always drowns out, and it's been tiled in the past. It's a really good soil, some of the best soil around. But the problem is it drowns out some, so we just put that back into a wetland restoration program. It's in a 10-year contract for that. So in closing, we use our technology on the farm in order to achieve conservation. So I'd say we're technologically driven, conservation oriented, and we're a family operation. Any questions?